Sharon Stone was walking down the road in 2001. She was a famous actress. She thought that somebody had attacked her and shot her in the head. She collapsed on the floor, was rushed to hospital, was actually treated for a ruptured brain aneurysm. Basically, a third of the people will die pretty much straight away, a third that will survive, another third that will need treatment for the rest of their lives. An entrepreneur or a founder is very enthusiastic about what they do. They'll often blind people with science. You gave me the ability to kind of stand back from that and see it from the other person's perspective.
Hello, Mike.
Hi, Beth. Nice to see you again.
Nice to see you, too. Thank you so much for coming and talking to me. I'm really interested to hear about your story about Endovascular, basically what you did before and how you started the company, what it is that you'd like to have happen with the company, where are you right now with it, and where do you see it going in the future?
Great. No, it's an absolute pleasure. Thanks for asking me along.
It's my pleasure. So just tell me, sort of your role in the company and where you started.
Yeah. So I am the CEO of Oxford Endovascular. It's a company that's a spin-out from the University of Oxford, and we're developing a technology to prevent brain hemorrhage or ruptures of blood vessels in the brain, basically. I've been interested in the area of medicine going back to when I was at school. I initially studied preclinical medicine. I wanted to be a doctor, and this was back in the 1980s, mid-80s, and after a few years of studying, I realised that I would probably end up as a tiny little cog in a great big engine, bearing in mind what was going on with the healthcare system in the UK at that time. And I thought, well, what's the best way for me to have some sort of major effect on how things are done or treatments, etc. And it was a kind of a turning point in my life. I decided to go to the dark side, as some people say, and to go into industry. And I started in the pharma industry for about 5 years, and then got a great opportunity to get into medical devices or medical technology. So that was the big turning point. And I've been in that environment for probably 25 to 30 years.
Now, for 25 or 30 years?
Something like
Developing medical devices.
Yeah, I'm not an engineer by background. I'm not that clever. My late father was an engineer. But I really built my expertise on the commercial side of the businesses and learned to essentially work with startup type organizations. Even the big companies I worked with were units where they had startups, and that's what really excited me. Seeing something go from inception, getting it to the market, and then seeing it in the hands of different types of doctors and seeing how it performed with patients to change lives.
So is then Endovascular, is this company, Oxford Endovascular, your first startup that you've been involved with? Or?
So it's my third major startup, if you like. But I guess what's unique about it is I've been there right from the beginning, or even before the beginning, because it was an invention that was in Oxford University. It had a little bit of grant funding behind it, but it needed the money raised to form a company, build a team, and then take something essentially from the bench and turn it into something which could be truly commercialized.
Well, I mean, I've worked with TNO in the Netherlands and a number of organizations that their focus is in developing technology, doing the research, but they want to commercialize it. And it's really hard to shift researchers and scientists' work or projects to the commercial environment. And so what you're doing with sort of at Oxford, where you're taking something from the bench and bringing it to the market, and then you've done this a couple times before, it sounds like, is something that should be in very high demand, right?
Yeah, absolutely. I think, the key thing, there are lots of fantastic inventions in many different universities,
right.
but often the key thing is there a real need for that? Has that been validated? So I guess where I came into this story was Oxford University approached me that heard a little bit about what I'd done over the years, and they said, will you come in and have a look at the technology, meet the inventors, and tell us if there's a market for this, and tell us what you think. We've heard that there is, but we don't really know how that's defined. So that was an opportunity for me to come in, have a look at what they were really talking about.
And how long ago was that?
So that was about 4 years ago, in fact. So we've been going for 2.5 years now. So effectively, for a year and a half, I was looking at this, building the case for this, and going out and working to get investors on board once I'd started to really believe in it and think, well, this could really be life-changing for not just for the patients, but for many others, investors included. Yeah.
So could you explain a little bit about what the technology is? How does it work?
So
And what's currently available versus what you've
I'll give you a picture of the marketplace. So we're dealing with an issue called brain aneurysms, which are weaknesses in the blood vessels in the brain that at any point could rupture and burst. Some people listening to this have probably heard of many situations where this has happened. Most recently, Sir Alex Ferguson, the ex-Manchester United manager, had a ruptured brain aneurysm. Totally undetected for many years and then suddenly ruptured. Sharon Stone, the famous actress, in 2001, she had a ruptured brain aneurysm and it devastated her life and ended her career. So most people have heard of people or in fact know people. In literally every week I hear of somebody who I know who has been touched by this disease. And
What percentage of them are fatal?
so if it ruptures, basically a third of the people will die pretty much straight away, and the other 2/3 you'll get a third that will survive, and basically another third that will need treatment for the rest of their lives, basically to prevent it from rupturing again. So if you can catch it before any of that, the idea is that you can stop it from rupturing.
So if you can catch it, means you have to know and have some means of seeing it, right?
Yeah.
So what's explained?
So the amazing thing is that there is the technology to identify this. So if somebody gave you a scan or me a scan, they'd be able to see whether we had a brain aneurysm or not. Bear in mind, 1 in 50 people have brain aneurysms. So, if you get a big group of people together at a conference, there'll be a significant number that will. The tragedy is that a lot of people just don't know that they have this. Typically, they're found by accident. So they go in for a scan for something else. It could be a soft tissue injury in the shoulder. Because doctors know that this is very common, they will look to see if there's an aneurysm there, and they'll tell
In the brain, even though it's a soft shoulder.
Yeah, because if they're doing, let's say they're doing an MRI scan or a CT scan, while they're there, they can
Look at your head.
literally look at what's there. And so often they will say to the patient, look, we can deal with your shoulder or whatever it is, or your carotid, but you've got something else going on there we need to deal with pretty much straight away. So that's the reality of the situation. Patients are often found purely by accident, and finding them by accident actually is a big enough market for companies like ours to be interested in, but it could be even bigger. So there are some countries that have already started to screen at-risk patients for brain aneurysm.
And how do you define an at-risk patient?
Yeah, it's a good question. So if you've got a family history, say, for example, if someone's mother or father has had a brain aneurysm, that person is 10 times more likely to have a brain aneurysm. So straight away, one could identify them as a potentially at-risk patient.
Wow.
Sadly, ladies are 10 times more likely to have brain aneurysms than men. We don't know exactly why. And of course, having cardiovascular disease increases the risk of either normal people who haven't got a history, but can multiply those with a history, again, hundreds of folds. Times more.
So just being a woman gives you, you're at higher risk in brain aneurysm than a man. So should all women be scanned, or is it something? I mean, like, what's the higher incidence? By a factor of 10, by a factor of 4?
It's by a factor of 10 for women. The places that are screening will typically look at. I was in Taiwan recently, just to give you an example. Age group 40 to 60. People with cardiovascular disease or a family history of cardiovascular disease, such as diabetes, something like that, poor diet, etc., smoking. If they're females as well, on within that, they'll break it down and give a scoring as to whether someone's at risk and to what extent. And that way you can basically identify the people who should be targeted to look at. That way, when you're doing an MRI, which, yes, it costs a few £100, so you're not going to do it on every single person straight away. But if you carefully target, you're going to find the vast majority of people who are going to have brain aneurysms. And that way you can then treat them, because there are various forms of treatments around. None of them are ideal, which is why we're here developing something for the future.
It is ideal.
Hopefully. But, you make something and then you want to, continually improve.
Right.
But, yes, you can identify someone, treat them, and prevent the misery of being permanently disabled.
Right, or dying.
Now, if someone's permanently disabled, that's a massive burden on society and the costs of healthcare. So if you're talking between 40 and 60, this is relatively young nowadays. This is considered relatively young.
Right.
And yet this age group is
at high risk.
At high risk, yeah.
Right. My brother-in-law's father died of a brain aneurysm. I think it was 42. So, it's... You say everybody knows someone. It's like I know of someone who's had it happen. So explain what's currently available and what you are doing that's different, better, etc.
Sure. So historically, the first way that brain aneurysms were treated was through open surgery. So a surgeon would literally open up the skull, delve around to find the weakness in the blood vessel, and put a little clip around the base of that weakness and pinch it off, if you like, to stop it filling up with blood and rupturing. That is still done to this day. It's still done in Europe, it's still done in the US, and if you look at China, that's the mainstay of treatment. Over the last 30 years or so, with the advent of keyhole surgery, so being able to put tiny little things into people's bodies through little holes in the blood vessels, so going into the leg, for example, and getting into the heart or getting into other blood vessels, people started to realise that they could place things higher up and into the neck and into the brain. So literally by making a little keyhole in your leg or groin area, getting into the main blood vessel there, passing up these little tiny tubes called catheters or microcatheters, getting it into the brain. And then they realised, well, if they can get access to that, if they could only put something through that will get into the aneurysm and do something, then they would have a chance of treating someone without having to open up their skull. So the real big...
How long ago was that?
Yeah, so that was about... people started to think of ways of doing that about 30 years or so. So it's actually fairly recent time in medical technology. The big leap forwards with dealing with aneurysms was some work that was done in California, in fact. And in fact, one of our inventors was involved in a lot of that work. And this was the development of micro coils, so tiny little coils of metal made out of platinum. And these could literally be put in through these microcatheters and dropped into the aneurysm one by one until they literally filled up the aneurysm and blocked the blood from going in. Now, this is all done under live X-ray, so the doctor who's performing this technique is not actually seeing exactly where they're going. They look at an X-ray, which is a moving image, and they have to have a 3D spatial awareness, a bit like flying a helicopter, if you like, inside someone's body. and they'll drop these little coils in and they'll fill the aneurysm up, and the idea is that that will prevent blood from getting in. And if you can prevent the blood from getting in, then this aneurysm is not going to get bigger and rupture. The big problem is that there are potentially a lot of complications with this, as with any interventional procedure. Because you're putting something inside the aneurysm is still effectively there. Mm-hmm. So it is potentially at risk of bursting. During the procedure itself, it's a very delicate procedure, and there is a risk of rupture because you're putting a catheter or this tube into the aneurysm first in order to drop these things in. So you can imagine you're dealing with something which is 2 or 3 millimeters across, and if you're putting a little tube in and you make one slight wrong movement, or it's not exactly where you thought it was, it's potential risk. Nevertheless, compared to open surgery, it's got very good success rates, and of course, the problems with open surgery of being under anaesthetic for that long, risk of bleeding on the table, long recovery, being out of work for a long period of time. It was a big, big step forwards. So now really what has been done is a combination of the two, depending on the situation, where the risk is, where the aneurysm is. But then people started to think, well, some of these aneurysms are quite big, and these little coils can often fall out of position. So they thought, well, maybe there's a way to stop them from falling out. People had already developed devices called stents, so little metallic tubes that can go into the arteries in the heart and essentially stop people from having a heart attack. Mm-hmm. Whereas historically they would have done open heart surgery. So I think a lot of people now have heard of, I had a stent put in last week and I went back to work and, I'm good now. Mm. So applying that concept to dealing with blood vessels in the brain, people thought, well, what if I could put one of these stents across the blood vessel that's got the weakness or the aneurysm on it and stop those little coils from falling out, kind of creating a little bridge.
Right.
So they started to develop smaller and smaller stents that could do that. And that is known as stent-assisted coiling. So you're doing two things to deal with a very, very difficult situation. And then after a while, they realized, well, if we can get a stent into position to stop something falling out of the aneurysm, what if that stent itself could stop the blood flowing into the aneurysm and putting that aneurysm at risk? So people started to develop the concept of a flow diverter, to divert the flow away from the aneurysm, but into the areas where it's needed.
And divert the flow of blood.
Exactly. And they realised that you only have to divert about 30% of the blood flow away from the aneurysm to cause it to start a self-healing process. I mean, our bodies are amazing. You can stimulate our bodies to actually treat themselves, if you like, under certain conditions. So basically, if you divert enough flow away from the aneurysm, you create coagulation in the aneurysm, so the blood goes slow and fills up and kind of creates a blood clot, which stops the aneurysm from getting bigger. And then over time, many months or even a year or so, that aneurysm will start to shrink and heal and disappear. Mm. So that created, and this was around 2008, 2009.
Sounds like a phenomenal outcome.
Yeah, a startup company, a little bit like ours, actually in the US at the time, created the world's first flow diverter. They worked to get a clinical trial done to show that it could be safe and effective in real human patients. And then they got the CE mark around 2009 or so. And that started the concept of using flow diverters alongside open surgery, alongside the coiling. So now you had kind of three key areas. There are a few other areas as well. As with anything, when it comes out, doctors have high hopes that everything is going to shift to this new technology. So you get these early adopters who start using it, pioneering it, pushing the boundaries, trying to use it in all sorts of different situations. Typically, when you get something approved, it's approved for a specified indication.
Right.
So it was originally indicated for where you can't use coils on their own, basically. But the pioneers pushed it into different areas and so on, and showed that it could be used in some different areas. But then, of course, when you push the boundaries, you start to see more complications. It's that sort of chicken and egg situation.
Yeah.
You find the equilibrium. So what they realised was that these early flow diverters, and there are a few different ones around now that various other companies make, have some challenges. And the big challenge is because they're made of woven mesh strands of metal, woven together essentially. So they can get them into position, but typically they don't have enough radial force to hold them in the blood vessels under every situation.
So they slip.
They can slip out of position. And that's particularly when you get a change in shape of the blood vessel, where a blood vessel may go around a corner. We call it a tortuosity. So under various different situations, the flow diverter can either slip or it can distort its shape and not have the flow diverting capabilities that they originally thought it would have. And so often what happens is they will put 2 or 3 in. Now these devices are not inexpensive. They cost several $1,000s. And they'll put 2 or 3 in to compensate for the one that may not work. So you can imagine that increases the costs. It also increases the time that the doctors have to spend putting these in. One typically takes about 40 minutes to an hour, compared to coiling, which can be up to 5 hours. So, there's trade-offs and payoffs. But of course, if you're having to put more in, that's more time, it's more theatre time, it's more people time. So all of these costs start to mount up. So every doctor wants something that works, first time, every time. So how do you do that? People are looking for new ways to do things. Is it a magic pill? Nobody's come up with a magic pill. That's some stage in the future. Is it genetic engineering to identify the right genes? That's some stage in the future. So we're still at the stage where mechanical intervention with a stent-like structure is really the gold standard of what people are looking at. So where our device comes in, it takes the concept of a flow diverter, the stent concept, but it makes it out of a unique design. It's not woven strands of metal anymore. It's essentially taking a tube of a very special alloy called nickel titanium or nitinol, which is used in a wide variety of medical prostheses. And you use a laser machine to cut a very unique design out of it, which is our patent-protected design that nobody else has been able to come up with. Our inventor, who's originally from China and works at Oxford University, got together, so he was an engineer, he got together with one of the world's leading doctors who treats brain aneurysms, and they came up with the concept of origami engineering for the brain.
I remember that from our pitch coaching from last fall.
Yeah.
When we were we were in Barcelona, right?
That's right. Yeah.
Yeah, and you came up with the origami engineering, and I thought, oh, that's super cool.
Yeah.
That sort of idea, and that phrase is just used for your device, right?
It's a concept we've borrowed from ancient history to
but you've coined
to apply,
that phrase for your device
to this, because essentially it's a structure that has a shape when fully formed is going to conform to the blood vessel around where the aneurysm is and have enough radial force along its length to fit and stay in place, but also to conform where the shapes are very difficult. And in order to get it in, it has to shrink down. So it has to collapse down into a much smaller size to get through that microcatheter and be deposited in the blood vessels in the brain and open up literally like a piece of origami.
Right. Yeah, I know, and I saw the photos of it when
Yeah.
you were pitching, and it's actually it's amazing. You know, it's like it's really really amazing sort of concept. So when you came into the company, they had already developed the device.
Yeah, so they'd got the proof of concept, they'd got the fundamental design, and actually applied for some of the patents. The big challenge was, so they'd done some preclinical work, they'd shown that it could divert the flow. But the big challenge was now to take this device and refine its design to make it even smaller to fit in that commercially sized microcatheter. And you're talking about something which is 27 hundredths of an inch in diameter on the
So you need to make it even smaller.
even smaller.
Yeah.
And the challenge there is when you make something smaller, which is made out of very thin struts of a metal alloy, those struts become very, very small. And you start to see the things that you may not have seen when you were doing the bench work. So you start to see things like it can deform and not recover its shape. You try and build it up and make it thick, and then it doesn't fit down the microcatheter. So you have to go through a lot of engineering work, computerized modeling, trial and error testing, fatigue testing, a whole host of
Which you did.
designs and tests, and we've essentially optimized the design, if you like, over the next year and a half. Yeah.
This coming year and a half, where you have been doing it.
Since we spun out, end of 2015, we spun out, and since that time we've refined it.
Okay. So, and then end of 2015, you spun out from Oxford, and so what funding have you gotten going forward? Because we met at the EIT Health. It's called Catapult. So they'd identified 14 medtech companies from across Europe that to come and compete to pitch, and they were narrowing it down to 7. So they had medtech, biotech, and digital health tech. So 14 companies in each of the 3 categories. You were one of the 14, and then I coached you in all 14 companies, and you were one of the companies that was selected, right, to be one of the 7 to pitch the final. In order to how much money were you pitching for?
So we were pitching for around £2 to £2.5 million
Right.
At that stage. When we'd spun out, we'd raised an initial seed funding of £2 million,
Right.
and we now needed more to take us through the rest of our preclinical work and further refinements on the device.
Right.
So we were pitching, for a 2 to $2.5 million. Yeah.
And so when you came to take my course, where were you once we met? Where were you in your business, and what sort of effect did it have on?
So we were at quite a critical phase because we were looking at cash out, I think, in the next 6 months or so. And of course, if you're the CEO of a company, cash is king. You've got to keep it coming in to keep everything going, your development, all your other work, pay the wages, etc. So my key focus was to raise the next round of funding. And of course, essential to that is being able to pitch effectively to investors.
Right.
And there's a lot that's involved in that. And even though I had pitched successfully to gain the seed funding, it doesn't necessarily get any easier. You learn a lot, but there's a lot still to learn. So I think going back onto a course to get critiqued and get constructive feedback put me in a much better position going out to seek that remainder of funding that we required.
And you raised it, right?
We did, yes. So
Congratulations.
yes, thank you very much.
Yeah, you're welcome. My pleasure.
Yeah, no, it was literally because I think the final of the EIT Health Forum was in November time, I think, and we were very fortunate. We were one of the finalists, and I think we came 3rd in the competition. So we won a little bit of money, which was very helpful.
Right.
But it really helped me to prepare for the subsequent investor pitches that we were lining up.
Right.
And then it was around just at the end of the last financial year, which is always important for investors to get the deal done. We managed to raise another £2.5 million pounds.
Right. End of last year.
End of the last financial year. So
yeah.
this calendar year, yeah.
Yes.
In end of April, basically.
Yes,
So, yeah.
right. Well, that's wonderful. Congratulations.
Thank you.
So
Yeah.
it sounds like my goal when I work with companies, founders, is to make sure that every conversation you have about your technology, service, or product counts, so that you understand how to create the core of what it is you need to say, the problem, solution, market, competition, your business model, your team, excuse me, your financial projections, and then your ask. You have to create the core of what it is you need to put out there, but then you're able to adapt it depending on who you're talking to. So it sounds like you're really good at doing that. It sounds like you've been able to understand how to adapt your pitch to whomever you're talking to, so they understand the value of what it is you're offering.
Yeah. I think that's always important. Whoever you're sitting in front of, you've got to really see where they're coming from, because you don't want to waste their time, and they don't want to waste your time. So you've got to try and tune into each other. So, often if I'm talking to a potential investor, I'll find out a little bit, get to know them, about their family history or their likes or whatever.
Yeah, who's in their portfolio?
Yeah. Are they a medical expert, or are they, someone just who is very altruistic?
Right. Philanthropy.
It just depends on, there's a full range you could be talking to. So, but you've got to try and, use the right language to meet their needs. If it's someone who has totally no medical understanding, then you've got to adapt what you're saying to make it understandable and sell the story.
Right.
Yeah.
So where are you now with the business? You've got the $2.5 million that'll last for a couple of years, and you're applying, you said, for your CE mark.
Yeah.
Or you're working towards.
Yeah. So at the moment we're doing some final preclinical work to de-risk the project, and this will give us essentially the data that we need to go out to another pitch with investors to get the final part of the money in, which will take us through a human clinical trial or first in human study in order to get the data required for CE mark to show that the device is safe and effective in humans.
And how much money are you going for next?
So the next round will be in the order of around 5 million.
And you need it by when?
Think. So that will be by the end of next year.
End of next year.
Yeah,
right.
so we're looking ahead. But of course, these things don't happen overnight. And I think one of the things that I learnt on the course with you, that this is a continual process. You're always promoting your business. You're always looking for that next fundraiser. It isn't just in this finite period of time.
Right.
And you never know who you're going to meet, who may be in a position to help you. We are very fortunate. We've got a great group of investors on board within our group now, and they do want to follow their money. So, as long as we keep convincing them with the data that's coming through, they will follow their money. But of course, one has to look ahead and think, where do you want to take the business? What types of markets are you trying to get into, and what regulatory approvals do you have to get through? So, at some stage, it will be important for us to have the right strategic investor who can help with certain markets, whether it be the US or China, for example.
Right.
Yeah. So we're already thinking about these important issues.
Right. So when you first came to my course, you're very articulate about what you're doing, etc. But what I found, what was our interaction? How did it help you sort of hone in on your message? Because I know when you first came to me, it was not quite clear enough about what it was you were doing, what was different, the problem, etc.
Yeah, I think when an entrepreneur or a founder is very enthusiastic about what they do, they'll often blind people with science, and it's very difficult to unpick that. So I think, what you gave me was the ability to kind of stand back from that and see it from the other person's perspective, and to distill down what are the real key elements going on here. What are the simple messages about the market? 750,000 people with ruptured brain aneurysms every year? What does that mean in terms of people who die? What does it mean in terms of people who will end up permanently disabled? So real headline numbers. Yeah. What does that mean to society? Okay. What is it about your technology that's different from everything else, out there? And what is the journey that you're going to take? How long is it going to take?
Right.
At which point you're going to be looking at getting a return on investment, and what do you need? How are you going to value your company? What's the future predicted value? Are there any other examples in the marketplace of what others have done in a similar space that you can use as evidence to justify your valuation? So I think these sorts of things you encouraged me to think about more critically. And I think the other thing was really the order of the story. So going back and looking at the slides and how they come across, so that it was a coherent message all the way through, with a strong opening, of course, to capture the imagination.
So give me your opening.
Well, I think one of the openings that I found is very useful is Sharon Stone was walking down the road in 2001. She was a famous actress. She thought that somebody had attacked her and shot her in the head. She collapsed on the floor, was rushed to hospital, was actually treated for a ruptured brain aneurysm. So the blood vessels in her brain had actually exploded. Luckily, she survived, but she spent the next year learning how to walk, to talk, and to remember who she was. And during that time of rehabilitation, her family broke down. She lost custody of her children. So it's that sort of devastating impact on someone who's in the public eye that other people can relate to. A young, working, successful, woman whose life is totally devastated by something like this, and has since gone on to do great work with brain aneurysm charities and so on. So I think telling that kind of story really brings it home to people.
Right.
Typically I'd do that in about 10 seconds, but I just added a little bit.
No.
But yeah,
I know. So you should grab their attention right at the beginning.
Yeah.
Because what I told you, I tell many of my clients that attention is the only currency that matters. And if you don't grab their attention, you don't get the resources, you don't get the meeting, you don't, they can't remember you.
That's
so
right.
so if they're going to, you could start out just explaining about the stint and the fact that you have a smaller stint, there's this many stints, and give some statistics.
Yeah.
But the story that you tell allows us to remember the sort of the impact of the devastation of the disease, of the illness. And then you can talk about your solution, and what you have and why is it better, and which is what you did.
Well, that's right, because once you've done that, they're now interested to learn more about it.
Right.
But if you start blinding them with technical science, you can lose people very, very, very quickly.
Right.
Yeah.
So, and that's my experience with many of the scientists that I coach, is that it's blinding them with science. Actually, I hadn't heard that before, but that's that's a very accurate and apropos phrase, because they give too many details about what's going on, and people don't generally care.
Yeah. I think it's a lesson that less is more. When you've got a 3 minutes or 5 minutes picture, it sounds, 5 minutes sounds like a long time, but it's not a long time. It goes very quick, but you've got to get a lot of information in the most optimal way.
Right, exactly. You have to be succinct, right? And choose your words and create your script really, really clearly, and be really clear about what's the one idea per slide, for instance, that you want people to remember. And then you practice it so that you can deliver it in a way that makes it not sound like you've already talked about this.
It's got to sound natural.
Other times.
It's got to be like a conversation with the audience.
That's exactly
that's
right.
very compelling.
Right, so that you can engage them as if they're, because with the audience, you're basically talking like you're one person to 5, or you're one person to 100 or 500, but they're not listening to you as if you're talking to them 1 to 500. They feel like you're having a one-to-one conversation with every single one of them.
That's
so
right.
your voice tone and how you deliver it, your body language, really, really matters.
Well, you mentioned voice tone. I think one of the things you did quite early on was to see how well people can project their voice, and you did a very interesting exercise getting people to say things in different languages or whatever.
Right.
And it was quite amazing, the range, because some people, you said, okay, just shout something out, and someone would shout, but it didn't sound like they were shouting.
No, it was very quiet, right?
So
Yeah.
so I think we don't always realise how other people are hearing us. So that was
Right.
a great sort of exercise and technique to get us to realise how we sound. Yeah.
Right. Oh, and it's about understanding that when you walk into a room, the burden is on you to make sure people can hear you. And so the idea of I ask people to whisper and then say it for one person, say it for 10 people, say it for 25. And what you're referring to is that, and say it for 50 people. The sentence they would say would be, they thought they were saying it for 50 people, but it sounds like it's only for 20, 25. So they can't project, right?
That's right,
And if you have a microphone, you talk as loud as if there's 2 or 3 people in the
Yeah.
room. So you wouldn't whisper or you wouldn't blast them super loud, but you need to be aware of adjusting yourself and the environment to suit you, but so that they can hear you.
Yeah.
Right.
That's right. And I think a doctor who I worked with many years ago, and we used to run courses together. One thing he always said was preparation is everything, and that's not just preparing your pitch, but it's also preparation around the environment. So
Right.
if you can do some reconnaissance and
Exactly.
find out where you're presenting, sometimes you can't and you're just dropped into it, but even going to the building
Ahead of time, right.
so that you feel more comfortable, you feel more familiar in your
Right,
surroundings.
right, and you see what the
Yeah.
constraints are,
Yeah.
and things that you can
Yeah.
change and the things that you can't, and
Well,
then how
that's
to
right.
adapt.
Yeah. I remember one pitch presentation I had to do last year, and it was literally, it was as though you were selling yourself in a pit, surrounded by about 30 people,
Oh,
and of course you couldn't face the audience, the whole audience at any one time. So you had to be comfortable to turn and walk and stand and
yes.
and do that. And that was a totally unexpected environment, but getting there early meant that myself and our chairman could scope it out for half an hour beforehand and work out how
to
we're going to
move.
handle
Right,
this.
right.
But
Right.
yeah, if you were just rushing in straight away.
Well, you have to be able to own the space
Yeah.
and really, really set it up to suit you.
Yeah.
And then you have to then move with intention. And so if you aren't sure, you're going to be awkward and hesitant. And, most of what they absorb when they're listening to you is your voice tone and your body language. The message is just a small part of
That's
it
right, yeah.
if your voice tone and body language don't support your message. So with you, your voice tone and body language supports your message. You're really clear, you're confident, you know what you're talking about. You've got this sort of compelling way of talking. So it's all all of it's copacetic. It's like all of a whole. So people believe what you're saying. And what I find is that some people, if they walk into an environment that they haven't sort of scoped out ahead of time and haven't sort of made their own by adjusting where they're standing and adjusting their voice, etc., so that people can hear them, if they're not aware of that and they don't act on it, then they lose their audience and they're conveying that they're not confident, which means people, what are venture capitalists really looking for? It's not just that you have an amazing technology. They want to know that you can execute on your idea.
They want to believe in you and your team.
And that you can, exactly, and that you can execute and you make it happen.
That's right.
And if you're conveying that you're hesitant or sort of uncomfortable, that's conveying the wrong information.
Well, that's right. I think there's a saying that a great team can sell an average product,
Exactly.
but a bad team can't sell a fantastic product. So
Exactly. And on that note, I want to thank you very much for coming and talking with me today, Mike. It's been really great.
Great.
And it sounds like you've just made a lot of progress since last fall.
Well, we're trying to. We're keeping going. It's you've just got to keep optimistic and keep working hard and learning all the time. So thank you very
You're
much.
welcome. It's been a pleasure. Thank you.